Alright, so today we're going to be looking at 7.2, the inverse trig functions. Let's just get right into it. So here for number 1, we have sine of, we have sine of cosine inverse of negative 2/3. Remember that when we see inverse trig functions, we think about how it's giving us an angle measure. So cosine of theta is giving us negative 2/3 there. And we know that inverse cosine has a restriction from 0 to pi. And because we see cosine as negative, we know that's going to be in quadrant 2. And then in quadrant 2, since we're working with cosine, we know we have adjacent over hypotenuse. So it does require us to figure out what this extra side is. So using Pythagorean theorem, we've got negative 2 squared plus b squared equals 3 squared. So b squared will equal 9 minus 4. And so b would equal to root 5 then. So we know that this side is root 5. So with that being said, now remember what we're looking for is sine of this angle. Remember that inverse trig is giving us an angle. So sine of this angle, well, if this is our angle measure that gives us this ratio, then sine would give us opposite over hypotenuse. So root 5 over 3, like that. Similarly, for number 2, we have sine inverse. So we know that for sine inverse, really this is asking us when does sine of theta equal root 3 over 2? And you can build your right triangle knowing that inverse sine has restrictions from negative pi over 2 to pi over 2. And sine is positive in quadrant 1. And sine would be opposite over hypotenuse. And then if we want to solve for that missing side, we can just use Pythagorean theorem. So we have root 3 squared plus b squared equals 2 squared. But in solving for b rather, you know that that value is just going to be 1. If you knew your unit circle values, you also know that's just going to be 1 as well. But what we're looking for here is cotangent of this angle here. And we know that cotangent really is the reciprocal of tangent, so that would be adjacent over opposite. So adjacent would be 1 over opposite, which is root 3. Or rationalizing that, we get root 3 over 3. Okay, so this is going to give us root 3 over 3. Keep in mind, if this is going too fast, just pause the video, rewind it, whatever you need to do to get the notes and understand these problems. Okay. Alright, let's go on to the next one. So here we have cosine inverse of 3/7. This is not a unit circle value, so this is just us having to actually draw out the triangle now, knowing that cosine gives us 3/7. Keep in mind with cosine inverse, you have a restriction from 0 to pi again. Cosine giving you positive in quadrant 1, and cosine being adjacent over hypotenuse. So in finding the, using Pythagorean theorem, 3 squared plus b squared equals 7 squared. So we got 49 minus 9. So it looks like we have the square root of 40 here then for the opposite side. So if we want to find secant of our angle, secant is really 1 over cosine of theta, or you can also think of that as hypotenuse over adjacent, same thing. So we can see that secant of theta then is going to give us hypotenuse 7 over adjacent 3, so it looks like we're just getting 7/3 here. In the next case, we have arctan of 1/3. So remember, arctan has restrictions from negative pi over 2 to pi over 2. I'll keep in mind that these are non-inclusive actually, as opposed to tangent, which was inclusive. So if it's positive, we want to be in quadrant 1, with tangent being opposite over adjacent. So again, let's find this side here. 1 squared plus 3 squared equals c squared. And in that case, we get that c is equal to the square root of 10. So in looking for cosecant of theta, which is technically 1 over sine, or that's the same as hypotenuse over opposite, then hypotenuse would be root 10 over opposite is 1. So we just get root 10 basically.
Yes!
Hey, shh. Okay, so now we do cosine inverse of 3 over 2. Cosine inverse has restrictions from 0 to pi. And then we know cosine is positive in quadrant 1. And cosine giving us a value of 3 over 2 would be adjacent over hypotenuse. Wait a minute, hypotenuses always need to be longest on a right triangle. So because 2 is definitely not longer than 3, this problem is not possible. And for this reason, this problem would actually have no solution. That was an interesting problem there. Okay, so let's go ahead and define the inverse secant. Yes?
You're just talking yourself. Nobody's listening.
Yeah, people will listen. Thank you. Okay, so define the...
Nobody's listening.
Okay, shh. So let's do the inverse secant, cosecant, and cotangent functions. So one thing to remember is that when you are working with secant, I'm actually going to erase some things here so I can draw it here. Hopefully you copy that down. If not, just rewind the video. But remember that in terms of the secant function, we're looking at how cosine looks, and keep in mind that there are asymptotes at those zeros here, and so the cosecant function is actually these values here, okay, like this. Now if we want inverse secant, keep in mind what we need to do is make sure we pass the horizontal line test. But currently it doesn't pass the horizontal line test because you can see here it has those two y values. So let's restrict the domain again, right here, cut it off. We don't want this section. So we go from 0, it works, horizontal line test keeps working all the way through, but then once you reach this point, it doesn't work anymore. So cut it off here as well. Okay, and what is that value? Look at that cosine function. This is occurring at pi. So that means that the secant inverse will have restrictions where it goes from 0 to pi. And the x values, you can see here, the x values need to start here and just work its way over to the right, which means x has to be greater than or equal to 1. Okay? Alright, we see that those the y values, rather, were always positive, so we're saying the absolute value of those values are going to be greater than or equal to 1. Alright, when it comes to cosecant, we're graphing the cosecant function. Remember, that's really looking at sine, and they have asymptotes at those intercepts, but then the cosecant function will look more like this. And so to pass our horizontal line test, we pass it, but then once you reach this point, look, it doesn't pass the horizontal line test anymore. So we actually need to restrict it right there. But keep in mind, this graph can go in the other direction. We need to make sure we have a little bit more, like this. And then the cosecant function would again have these spots there. And it passes the horizontal line test here, but it doesn't pass it there. So we have to stop it there as well, which means we're stopping it from here to here. And if you look at those values of sine, that's going from negative pi over 2 to pi over 2. Again, x has to be greater than or equal to, notice how it's always above the value of 1 here, and we're using the absolute value, so it always has to be greater than 1. Okay? Now notice one thing about these, though, is that they do have these restrictions, because you did have the asymptotes occur right here on cosecant. Notice that occurred at 0. That's why it says y cannot equal 0. In this case, the asymptote occurred right here, so we can't have it at pi over 2. Okay, so you have to have those restrictions as well. Keep in mind, we're talking about the inverse function, so we're taking this and being able to invert it along the line y equals x, and so we're getting its reflection across that line there. Now, cotangent inverse is a little bit more interesting. If you recall what cotangent inverse, or rather cotangent, looks like, the cotangent graph looked like this, with asymptotes right there. That asymptote was at pi, and also at 0. So for that reason, when we reflect this across the line y equals x, remember that x's and y's switch. So when you graph its inverse, let's think about what's going on here. If normally you would have had a point over here, let's say this is going to like pi negative infinity, basically. Remember that x's and y's switch, so now we're going from negative infinity pi. So negative infinity pi would take us like to a point up here, and so we'd end up getting an asymptote at pi, like this. And then over here you have a point that's going way up here, all the way to like 0 infinity, basically, right? That point is almost like 0 infinity, with the asymptote occurring there. So 0 infinity, if they swap, you'd end up going to infinity, infinity, comma 0. So it's going all the way over here. So you can see that this graph, when it gets reflected across the line y equals x, you actually end up with a cotangent inverse graph that would look like this. Which means if this is your graph, notice how the domain restriction and the range actually get restricted. The range goes from now 0 all the way to pi. 0 to pi. And then the x values, you can see, goes all the way from negative infinity all the way to infinity. Negative infinity to infinity. Okay? So, cotangent is a little bit interesting. Because it has the restriction from 0 to pi, you almost think of it like having the cosine inverse restriction from 0 to pi as well. So that's going to come into play as we look at the next few problems, where when you do cotangent inverse, it's not going to be that the idea where, tangent inverse, its restriction was negative pi over 2 to pi over 2. It turns out that cotangent inverse has the restriction very similar to cosine, which is 0 to pi. So that's one thing. Okay, thank you. So that's something we have to keep in mind. Okay, so let's go ahead and take a look at our next few problems here. So find the exact value of cosecant inverse of 2. As we do this problem, remember that really what this is saying is x equals cosecant inverse of 2. So that's saying let's do cosecant of x equal to 2. Cosecant is really the same as 1 over sine of x. So if we have 1 over sine of x equals to 2, that means, let's just switch these, so sine of x is equal to half. Okay, when is sine of x equal to half? Well, if we do this on the unit circle, keep in mind that it has the restriction from negative pi over 2 to pi over 2. That means it only occurs here. And we just think, when does sine of x equal to half? That's going to be at what degree? That's going to be at pi over 6, like that. Okay? Alright, let's go on to the next one. Use a calculator to approximate each expression in radians rounded to 2 decimal places. So we have secant inverse of 3. So if we do this, this is like saying secant of x equals 3, which is really like 1 over cosine x equals 3. Now keep in mind with secant inverse, it had the restriction with looking like this, right? This is what our secant graph looked like. We had the restriction from 0 to pi. So we only want to go from 0 to pi here. Okay? So in doing that, this is like saying let's find cosine of x equal to 1/3, but only go from 0 to pi. And that occurs only in quadrant 1 here. Okay? So we're going to have to use our calculator now and do cosine, basically cosine inverse of 1/3. That's what we're entering into our calculator. Okay? So let's go to our calculator. Since it's not a unit circle value, now we're doing second cosine inverse of 1/3. And we get a value of 1.23. Okay, so this answer is 1.23. Okay, let's go on to the next one. So now we're going to do cosecant inverse of negative 4. That's really the same thing as saying let's find cosecant of x equals negative 4. Or that's like 1 over sine of x equals negative 4. Which, if we move things around, this is the same as saying
just use this?
Sine x equals negative 1/4. Okay, and so so then because we're looking at cosecant, keep in mind that we have that restriction from negative pi over 2 to pi over 2, and so that's going to if sine is negative, that's occurring in quadrant 4 there. So we're doing sine inverse of negative 1/4. Let's do that. Sine inverse of negative 1/4 gives us negative 0.25. Okay, so this answer is negative 0.25. Okay, so now let's do cotangent. Oh, remember this one. This one's a little bit weird. Cotangent inverse of 1/2. Keep in mind what we said earlier, that cotangent inverse, it's got that weird restriction right here from 0 to pi. So keep that in mind. We really want to be looking at it as a cosine function. Okay, so let's do that. So this is saying cotangent x equals 1/2. Okay, And so keep in mind that cotangent is really the same as 1 over tangent of x. And if that's equal to half, then it's like saying, let's do tangent of x equal to 2. Okay? So, in that case, I'm going to just draw it over here. Keep in mind that cotangent inverse had a different restriction. It wasn't negative pi over 2 to pi over 2. It was 0 to pi. Okay? And when is tangent value positive? That's only positive in quadrant 1. You actually don't want it in quadrant 2. So this is going to be a little bit different now. Now keep in mind that tangent is opposite over adjacent, which means opposite is 2 and adjacent is 1. Okay? And so let's find this other side here. That's going to be 1 squared plus 2 squared, and square root of that, so that's going to be the value of square root of 5. So when doing this value, keep in mind that really what we're trying to do is, because it's the restriction from 0 to pi, think about it as the cosine inverse. So we're going to do cosine inverse of, so if we use this triangle here, we have cosine is adjacent over hypotenuse. So we're doing cosine inverse of 1 divided by 5. Okay, let's go ahead and do that. Come on. There we go. Cosine inverse of 1 divided by square root of 5. And we get a value of 1.1, and let's round that to the nearest hundredth. So 1.11. Okay, so this value is 1.11. Okay? Alright, let's do the next one. Cotangent inverse of negative 2. Okay, so just recall this is saying cotangent of x is equal to negative 2, or 1 over tangent x equals negative 2, or tangent of x equals negative 1/2. Just rewriting that. Okay. So if tangent of x is equal to negative 1/2, we think about where we are with the restriction of cotangent, very similar to cosine inverse of 0 to pi, and tangent gives us a negative value, this time in quadrant 2. Okay? And if we look at the tangent value, which is opposite over adjacent, then this is going to be 1 over negative 2, like that. Solving for our hypotenuse, just like this triangle here, it looks like the hypotenuse is going to be root 5. Okay, so in finding the 3 parts of our triangle, let's now go ahead and remember that because tangent has a restriction from 0 to pi, cotangent inverse has a restriction from 0 to pi, we need to use the really more like a cosine inverse value. And so cosine is going to be adjacent over hypotenuse, so negative 2 over square root of 5. Okay, so if we go ahead and type that into our calculator now. So we do second cosine inverse of negative 2 divided by square root of 5. We'll get a value of 2.68, basically. 0.68. Okay, so this value is 2.68. So keep in mind those restrictions. I think if you enter these values into your calculator outright, it doesn't exactly come out very nicely. So you do have to do the work involved here by hand, because I think for some of these, if you try them just outright like that, it's not going to work. We don't even have these functions in the calculator, so that's why we do need to rewrite these things. Okay. I know I was speaking fast. I was kind of trying to get this video finished in a certain amount of time, but if you need to, always rewind it, copy those notes, and just listen to it as much as you need to make sure you understand these concepts. Okay? Alright, well, have a good day, and now start your homework. Alright, bye.